Hi, and welcome to the short video tutorial on the use of the BiclustGUI R package, a plugin for R command. With this GUI you can easily apply many different biclustering algorithms on your dataset. It includes methods such as plate, bimax, fabia, isa, and many more. Now, the easiest way to launch the GUI is by simply calling the library directly into the R console. Anyway, before we start with the tutorial, if you need any additional or more detailed information, this can all be found in the vignette of the package. You can access this vignette very easily by going to the biclustering help and utilities, help and documentation, and then vignette BiclustGUI. So, now that the GUI has started up and we know where to find the additional information, let's first begin with loading in some example data. For instance, let's use the bicat yeast dataset. This is an example dataset in the Biclust package. We can load this in very quickly by using the already existing features in R Commander. First, go to the Data menu, Data and Packages, read dataset from an attached package, select the Biclust package, then the Biclust yeast dataset, before pressing OK. We can already see that the corresponding R code to this load process is being generated in the script window and that an active dataset has been set to the bicat yeast. Let us now continue with applying an actual biclustering method on this dataset. Let's say, for example, if we would like to apply a plate algorithm. Then we go to the biclustering menu, we select the biclust menu, and then biclustering plate. A new window has now appeared, containing everything we need to execute the plate method. First off, note that this window exists out of two separate tabs. We will first start in the first tab, in which we actually set our parameters for the method, then continue on to the second tab, in which we'll be able to make some graphs of our results. The structure we see here, namely the two tabs, is used in each of the implemented biclustering methods. So let us now do so and just simply use the default filled-in parameters before pressing the Show Result button. Also note that you can set a seed on each time you use an algorithm by the use of the seed box in the bottom of the window. Once again, we see the R code appearing in the script window, which is responsible for the execution of the plate algorithm. You can also already see a small summary of the results in the output window. For example, here we can see that 5 biclusts have been discovered by the plate algorithm. Now, as I explained earlier, the next step will be to go to the second tab, in which you can visualize this result. For example, to start with, we could ask for the F statistics of the first bicluster. This gives us the F statistics and the p-values of the row and column effects, as well as the two-key test. After this, we could also bootstrap these first two F statistics for the same bicluster and even visualize this. Another nice way to visualize a first bicluster is through the use of a profile plot. Let's choose the combined plot type and then press the draw button. Again for the first bicluster. Now, in this plot we can actually observe how different the gene profiles in our selected bicluster are from those outside the bicluster. Still, another way to investigate our bicluster is with a heat map plot. We shall first uncheck the local options, so we will plot the entire data matrix. You can see that our chosen bicluster is located in the top left of the plot, showing a similar pattern. There's still some more graphs which can be used for this method. For example, a bubble plot, a bar plot, or a bar chart plot. But for now, let us explore the functionality of the diagnostic package called bcdiag. Again, by doing so, a new window opens on top of our previous window. At the top again we find the bicluster number, which will now affect all of the diagnostics in this dialog. For example, we can take a look at some exploratory plots of the first bicluster with the button over here. More profile plots are also available in this window through the buttons down here. This window of the bcdiag package is available for all of the methods in the GUI, not only for the plate method. Now, let's take another method to show some examples. This time we will go to the isa method. Again, we go to the biclustering menu and then we select isa. Again, let's just take the default parameter and see what happens. After going to the second tab again, we can take a look at the summary of the isa result. We see that 157 biclusters are found and the top 10 biclusters based on the robust score are reported. Note that some of the diagnostics are the same as for Blade in this window, but there are also some other things specific for ISA, such as the score plots. On this plot we can find the row and column scores for certain biclusters. It's a score between -1 and the further away it is from 0, the more association there is with the bicluster. Finally, going down to the bottom of this window, we can once again find the BC.diag package. But this time let's take a short look at the Super Biclust package right next to it. This package tackles the problem of biclustering instability. It will construct a hierarchy of biclusters based on a certain similarity measure. The first thing we could actually do in this window is add more results from other methods to base this hierarchy tree on. This is done with the Choose button. As expected, the plate result we did before ISA is showing up. We can select it and press OK, and it will be filled in the previous window. However, for this example, let's just only use the ISA result. We can now choose which similarity measure we would like to use, as well as on which dimension. Let's keep it on its default settings and then press the Super Biclust button. After this completes, we can press the Draw the Tree button to see the result. The next step would be to either choose the number of biclusters we would like to have, or a certain height to cut the tree at. Let's cut the tree at 0.6 and look at the resulting robust biclusters. We can look at the resulting robust biclusters by pressing the Robust BC button. In this small output we can quickly see how many of the old biclusters are in our new robust biclusters. If we would like to know which ones, we would have needed to check the Show Inside option as well. Finally, we could also save these new robust biclusters with the Save button on the bottom of the window. If we would now go back to the previous window, we can do diagnostics of these results. However, do note that only the biclust plots and the BC.diag plots will be functional. For example, we could again plot a profile plot of the combined rows and columns of the first bicluster. This is now a plot of the first robust bicluster containing two other biclusters. However, if you would like to go back to the previous or original result, you can simply go back to the Super Biclust window and press the Reset button. If you would plot the same profile plot again, you can see that now only the first original bicluster is being plotted. Now, this concludes the first tutorial on the BiclustGUI. In the second one, we will shortly look into the extra utilities available in the GUI in the Biclustering Help and Utilities menu.